Hi friends, this is Syed Reshma Sharif. Today I am going to discuss a topic that is qualitative theory of a PN junction diode in electronic devices and circuits. Now, how the formation of PN junction diode, let us discuss. In a piece of semiconductor material, this is a piece of semiconductor material. Okay, if one half is doped with p-type impurities as well as another half is doped with n-type impurities, then this forms a PN junction diode. Okay, it forms PN junction diode. See how it's simple? Or the plane dividing the two halves on zones, it is called PN junction. Or simply we can say the plane dividing the two halves on zones is called PN junction. Okay. Here the plane that which divides the two halves, this half is there, isn't it? This is p-type impurities, this is n-type impurities. This part is called PN junction. Okay, the p-type semiconductor consists of both holes and negative acceptors ions. Okay, the acceptor impurity atoms is short of one electron and becomes a negative ion. See, what is this? It's p-type semiconductor. P-type semiconductor consists of both holes and negative acceptor ions. These negative acceptor ions, what they do? They accept impurity atoms. They accept impurity atoms is short of one electron and becomes a negative ion. The acceptor impurity atom is short of one electron and becomes a negative ion. Similarly, in n-type semiconductor consists of both electrons and positive donors. A p-type semiconductors consist of both holes and negative acceptor ions, whereas n-type semiconductors consist of both electrons and here what they will present? Donors, that is of positive donors. Ion are present. Okay, here what they present? Negative acceptor ions, where in n-type positive donor ions. These positive donor ions, they combine with these and they give negative acceptor ions. Okay. Here the donor impurity atoms donates one electron and becomes a positive ion. Here what it will do? It will donates one electron. Here what it will do? It will short one electron. It will short, it means reduction of one electron. Here what it will happens in n-type semiconductor? One electron donates. Okay, here one electron shorts, whereas here one electron donates. Okay, this is the difference between p-type semiconductor as well as n-type semiconductors. Okay, here n-type material has high concentration of free electrons, whereas p-type has a high concentration of holes. We already discussed, isn't it, majority carriers and minority carriers. Majority carriers are more. Which majority carriers are more in n-type? Electrons are more, whereas in p-types holes are more. Based upon that point, this point will depends. Here n-type material has high concentration of n-type material high concentration of electrons, that is of free electrons. N-type material has more concentration of free electrons. Okay, while p-type has high concentration of holes. Okay, here are free electrons in n-type, whereas in p-type holes. Therefore, these results in the junction side there is a tendency of free electrons, tendency of free electrons to diffuse over the p side. Diffuse over the p side. Here free electrons, that is diffuses over p side. Okay, and the holes to the n side, and the holes that are to the n side. This process is called diffusion. Again, I am saying that these n-type have concentration of free electrons. Okay, similarly p-type has more concentration of holes. This gives result in junction side there is a tendency for free electrons to diffuse over the p side. Okay, here electrons majority carriers for n-type semiconductors are electrons, whereas majority carriers for p-type semiconductors are holes. So for this process there is a tendency for free electrons to diffuse over n-type semiconductor to p-type. Okay, and from p side to holes, and p side to holes. From n side electrons diffuses, from p side this holes diffuses to this side. This process, entire process is called diffusion. See how easy it is. Based upon the concentration of electrons as well as holes, from p side to n side the holes will move, and from n side to p side the electrons will diffuses. This entire process is called diffusion. Okay, as the free electrons moves across the junction from n type to p type, the positive donor ions are uncovered. Hence, a positive charge is built on n side of junction. This is one process of diffusion. Next, let's see. Don't get confused. Till here what we discussed, what is PN, how would PN junction form? P majority carriers in P type and minority carriers in P type, and N type similarly we discussed. N type there are more concentration of free electrons, P type there is more concentration of holes. So here diffusion process means from P side to N side the holes will diffuse, whereas from N side to P side the electrons will diffuse. This entire process is called diffusion. Similarly, the donor in P type the donor will present. In N type the acceptor ions will present. See, let us see, as the free electrons moves across junction from N type to P type, and positive donors are uncovered. This N type to move P type electrons moves. At this time the positive donor ions are uncovered. Hence, a positive charge is built on n side. Hence, the positive charge builds towards the n side. Again, see, as a free electrons moves across the junction from n side to p side, positive donors are uncovered. Hence, the positive charge is built at n side of the junction. Okay. At the same time, the free electrons cross the junction and uncovered the negative acceptor ions by filling in the holes. Hence, a net negative charge is established on p side of the junction. Similarly, some electrons moves from n side to p side, isn't it? Here it builds a negative acceptor ions by filling the holes. Here majority carriers are holes or not? These holes are filled with these electrons and uncovered the negative acceptor ions by filling the holes. The electron fills these holes. Okay. Then negative charge is built at p side. Negative charge is built at p side of the junction. Now the positive charge on n side, whereas negative charge on the p side, it indicates that the free electrons to enter from n type to p type. Here the two charges will be formed. Okay, here at n side positive charge, whereas at p side negative charge will be formed. This positive charge on n side repels the holes from p side to enter to cross the junction. Similarly, the negative charge at the p side repels free electrons to move towards the n side. Okay, enter from n type to p type. This barrier is set up against further movement of charge carriers. This is called potential barrier or barrier potential. This is called potential. From these two charges are useful for repels the holes from p side to n side, from electrons from n side to p side. Here it forms a barrier or not. Barrier means nothing but bridge type. This is called as a potential barrier or barrier potential. Okay. Or junction barrier. At junction side only, na, so it is also called as a junction barrier. Clear? This is the entire potential barrier. Okay, how this is of p type semiconductor, this is of n type semiconductor. Here negative charges, here positive charges. This is a depletion layer. Here it layer forms, the negative charge is formed at p side, whereas similarly a positive charge formed at n type semiconductor, n side. Okay, this is based upon the positive donor ions as well as negative acceptors. Okay, negative acceptor ions. Here the barrier potential indicates the amount of voltage. Some kind of voltage will be formed in this depletion layer, isn't it? This barrier potential indicates the amount of voltage to be applied across PN junction to restart the flow of electrons and holes across the junction. So we have to apply some voltage or not for movement of electrons and holes like this. Okay. So here the voltage is applied across this junction. The barrier potential is expressed in volts. Okay, this is expressed in volts. Which one? This barrier potential or potential barrier or junction barrier. This is indicates as or expressed in volts. Its value is called the height of the barrier. Its value is called as the height of the barrier. The magnitude of barrier potential varies with doping levels and temperature. Doping means we already discussed now how PN junction is formed by doping some p-type charge carriers and n-type charge carriers and semiconductor. This is called doping. This potential barrier can be increased or decreased by applying an external voltage or the magnitude of the barrier. It depends upon the doping of electrons and holes in p-type and n-type. Okay, doping levels and its temperature, the magnitude. Similarly, the potential barrier can be increased or decreased. It is based on applying external voltage. If we apply voltage across this junction barrier is more, then concentration of electrons and also holes are more. If we apply less voltage here, automatically it will reduce. Okay, the potential barrier is approximately 0.7 volts for Si and 0.3 volts for germanium. 0.7 volts for silicon, 0.3 volts for germanium. You have to remember this one because these two maximum we are using for these semiconductors. The thickness of this region, it means inside the potential barrier there is a positive charge or N side. Okay. Similarly at P side there is a negative charge. This region is called as a depletion region or space charge region. This is called as a depletion layer or depletion region or space charge region. Okay, the thickness of this region in order of 10 power of minus 4 centimeter or 10 power of minus 6 meters is equal to 1 micron. This is a main thickness of region in order of 10 power of minus 4 centimeters. Which region? This depletion region. In next video we will discuss how the formation of PN junction diode and all. Thank you for your watching. If you have any doubts regarding this, please comment me on my comment section.